Today we're going to make a Slayer exciter. This is the simplest kind of Tesla coil that you can make. It's so fantastically simple to make, you've just got to make one. Just get the parts and make one. You've got to do this yourself and see this because it's so easy. So what do you need to make it? Well, a bit of PVC pipe. This is about 1.5 inches in diameter. You need some wire for the secondary. That's the big coil that's going to go along the pipe. And this is 0.6 mil. It's 22 gauge. The only reason it needs to be thin is because you need to get 200, 300 turns on here. And if it's not thin enough, you're not going to get enough turns on there. You need some wire for the primary, which goes around the base. And you only need about 5 turns of that. This is about gauge 12. The thickness in this case doesn't really matter because we're not putting a lot of power through it. But just find some wire that looks reasonable. You can always try a different wire if it doesn't work, but it probably will. You need a transistor. This is just a 2N2222A transistor, NPN transistor. It's just basically the most common transistor around. You need an LED. Well, you actually need a diode, but using an LED, which is a diode, it's a light emitting diode, is really convenient because it will light up when the circuit's wired up correctly. So that's actually very handy. And you need a resistor. Now, interestingly, I've noticed that the circuit works even without a resistor, but let's put one in anyway. So that's it. There's just 1, 2, 3, 4, 5, 6 bits that we need there. The first step in winding the secondary is you need to attach the wire to the PVC pipe. So I'm just going to use a little bit of tape here, a bit of duct tape. And I want to leave a little bit of excess there so that there's something to work with, once it's wired up. So I'm not going to start right at the beginning. There you go. That's just put it on a bit. I might put a bit more tape on there. But that's the first step. The next step is to wind 300 or 400 turns of the secondary on the PVC pipe. You can do this in lots of different ways. You could do this manually, unfortunately if you haven't got a lathe. We happen to have a lathe and this makes it very easy to do.
Okay, so this is how you wind a coil. Start it off and tape it down. Fix it firmly because you're going to have to put quite a bit of force on it so it's going to snap off. You don't have to worry about distorting the end there because normally when you finish off the coil, it'll either spring back in place or if you want to cut the end off once you fix this end of the coil. You need to keep a reasonable amount of tension on it and with a slight bend that way so that the wire kind of laps onto there and then snaps back into place and you make a nice tight coil like that. Now keep the tension on, turn the lathe slowly to get it going. I've wound a couple of these to start it by hand, then I wound a few more and then I pulled it down onto it by turning the lathe off to make sure that the start was neat. Once you've got that bit going, you can start the lathe up, don't turn it too quickly. It'll wind all by itself. See there's little gaps there? If you start getting little gaps there, just push it down with your thumbnail to neaten that up.
Yeah, since it's
So when you wound the coil, just finish the ends off neatly with a bit of tape. So you take a little bit, wind it around, tighten it up, give it a good pull, and then just wrap a bit of tape around it to make it look nice and neat, because you put a fair bit of effort into it, so it should look nice. And there we go. There's our coil.
The next stage in the coil construction is to wind the primary. This needs to overlap the secondary to get a good coupling. So what I'm going to do is just tape it on a little bit. And this is nowhere near as crucial as winding the secondary in terms of precision, because it's a piece of cake. We only need 5 turns here. Okay, there we go. So the primary is now wound on. So I need to trim these off. I'm going to attach a little bit of wire onto there, and then we need to wire this thing up. So just to make it look neat, I'm going to put it on a board. So I want a way to mount the coil to this piece of wood. I found this little pot, and it just so happens to fit perfectly on the inside thread of the pipe. So I'm just going to glue that on, and then I can just slot the coil on. Right, so now we're going to construct the circuit. It's very simple. There's lots of ways you could put it together. You might want to solder the stuff together directly. You might just want to twist the wires together. What I'm going to do is I'm going to put it on a bit of perfboard just to make it neat. So the circuit's very simple. If this is the transistor, and with its flat facing backwards, we have the collector, the base, the emitter. And now I'm going to put it in this little header, because I know I'm going to burn some of these out, messing around with maximizing the power and so on. So this is how you're going to connect it up. To the collector, you're going to connect up one side of the primary coil, and the other side of the primary coil is going to go to your power supply, your positive rail. To the base, what you want to connect up is a resistor, the other side of which will go to the positive rail. This is a 10k resistor. You might want to use a larger one or a smaller one. Experiment around. 10k will do just fine. And then to the base, you also want to connect the LED, and connect the negative side of the LED to the base and the positive side of the LED to ground, because this is in the reverse direction, so from ground to the base. You can tell which is a positive because it's usually the longer one. Otherwise, check the spec sheet of your LED. Also to the base, you want to connect one of the wires of the secondary of your coil, so the big long coil. And then to the collector, the third pin here, connect this directly to ground. And that's actually it. That's all the connections you need to get it operating. It's always handy to have a schematic so you can pause it, because it's quite difficult to follow when someone's connecting it up in front of you like I just did. So just to quickly show you, you've got the power source here, 3 volts plus, and on the positive rail we've got 3.3k in my case. You probably want to put 10k on there. Going into your base of your transistor. Also going into the base of the transistor is one of the wires of the secondary, and also going into the base is the LED in this direction going into the base. Going into the collector of the transistor is your primary, and that's coming from your plus rail. And then the output of the transistor, the collector, so the emitter, is going to ground. And what you'll observe here, just with these 2 dots, means that these coils are actually wound in the opposite direction. You don't have to worry about that, because when you connect up your primary, what you're going to do is you're just going to switch the wires over until this LED lights. So don't worry about winding them in a particular direction on the PVC pipe. One of the things you'll need to do in order to connect the secondary is make an electrical contact with the end of the wire. Because it's enamelled wire, you've got to get the enamel off. I found the easiest way to do this is just to scrape it off with a razor blade. Turn it round and just scrape it off each side until it's all scraped off, and then that makes a great electrical connection. There we go. Finished circuit on perfboard. Now just to wire it up and test it out. All right, the circuit's complete. Just a quick note about winding the primary. You've got to make sure that the polarity is right. It'll only work with them connected up in one direction. The way you can check that is that the LED will light once it's working. So let's connect it up to a 9-volt battery and check that out. Wireless power transfer. Look at that, that's amazing. Absolutely fantastic. And do it with a bigger CFL as well. Look at that. How cool is that? I just love that. That just blows me away. All right, so there you go. That's how you build yourself a Slayer. I've just come back to the bench and I've connected it to my bench supply at 5 volts. I found at 9 volts it was burning the transistors out quite quickly, whereas at 5 volts it doesn't burn them out at all. So I find this personally really fascinating. You know, what's happening here is that the electromagnetic field is causing the molecules within inside this tube, because there's hardly any of them, so they can move about quite freely, to bash. It's pulling them towards the coil and away from the coil, or towards the field and away from the field, so rapidly, and they're bashing into the phosphorescent coating, which causes the illumination. And that is amazing. I could stare at this thing all day. It's fantastic. Well, anyway, I hope you go away and make one, because we'd love to see we'd love to see it. I hope that was useful. Thanks for watching.